In this lesson, we're going to look at putting all these transformations into one graph now. So we've looked at the effect of A, K, D, and C, and now we're going to put this all together. So let's recall some terms for a moment. So first of all, the term period means the length or distance it takes for a function to repeat itself or for a cycle. The amplitude is half the distance from the max to the min. So the formula for that one is half the distance would be max minus min divided by 2. Okay, and that will give us our amplitude. So we looked at that earlier. The vertical shift, we haven't looked at a formula for that, but that is a shift up or down. We can imagine the vertical shift, since that finds the middle point of our graph, it would mean looking at the maximum and the minimum and finding the average of the two. So to find the average, we add the two up and we divide by 2. So we can think of the vertical shift as max plus min divided by 2. And that gives us our C value in the equation. And lastly, we have our phase shift, which is a shift right or left. And this one's a little less clear to actually figure out because it's periodic and a sine function repeats over and over. So there's going to be more than one value you could choose for your phase shift, whereas the other three items, they are always set. You can't change what that would be. And you'll notice that in this form, so if we're looking at sine, that the inside of what's inside the sine function should be factored. So in other words, we have that k value taken out, and then we have the d. So you'd never want to have kx minus kd, because that would look as if the phase shift is kd. And what we want to have is the factored form, and then we can tell what the d value is very clearly. Okay, so we're going to look at some examples in a moment, but so we have spent the past several days learning about these terms and how to add, subtract, multiply, and divide. Different values affect and how they affect the graph like sine and cosine. Today we are going to put it all to the test. By the end of this lesson, you should be able to write the equation of any sine or cosine function graph, and you should be able to graph and describe any sine or cosine function. So when we look at this, the formulas here, just putting them all in one spot. The amplitude is max minus min divided by 2. The k value can be found with 2 pi over the period. And fun fact, it's also period equals 2 pi over k, and I'll leave that to you to figure out how these two transform to each other. But those two formulas are interchangeable, so typically if I'm trying to solve for k, I'm going to use this formula there, k, but if I'm trying to find my period, I'm going to use that formula right there. D is the phase shift, and like I said, I won't give you a formula for that. That one involves a little bit of creativity. And the vertical shift is max plus min divided by 2. Or another way to think about it is if we just take the max value and take away the amplitude, we should get the equilibrium, which is C. Or you could think of it as min plus the amplitude, and that would give you C. All three of these formulas are useful in their own little way to figure it out. Okay? So we're going to walk through this with an example. We're going to look at a graph, and so we can see this graph looks like some kind of sine or cosine function. It's repeating itself. It's going up and down and repeating itself over and over. And we'll go through these values one at a time, the A, K, and then C, and then we'll go to D. So I'm going to suggest you do A, then K, then we're going to shift over to C, and then we're going to go to D and figure out what to do. So A is locked in. It's the amplitude, which is max minus min divided by 2. So we can see that A equals the max right here, which is -1, and this right here is our minimum. So it's max minus min, so -1 minus -5 divided by 2, which is -1 plus 5 divided by 2, which gives us 4 over 2. Well, look at that, I have a mistake. What was the formula? It's max minus min, -1 minus -5. Oh no, I'm right. Everything's working out great. My apologies. And then we get the amplitude is 2. I was thinking about another value ahead of time. So we got A equals 2. Next, we have our K value. So first we need to figure out what is the period. So if I think of this as the starting point, we got to say, well, when would this graph start repeating itself? And so you can see that if you were to slice it right there, we'd see that every 4 units, it seems to repeat itself. So we're going to put k equals 2 pi over the period, which is 4. And simplified, that is pi over 2. Next, we're going to figure out the C value, which is the vertical shift, and that is max plus min divided by 2. So C equals max, which is -1, plus min, which is -5, divided by 2, which gives us -6 over 2, which gives us -3. And that makes sense. You might not even need the formula, because you can see that -3 seems to be our equilibrium. It's right in the middle there. From here we go 2 up, from there we go 2 down, and we've got our middle value there. All right, now the tricky part, the D value. So if I were to call this a sine graph, now remember we got y equals a sine bracket k x minus d bracket plus c. So we're going to write down y equals, I guess I should be using f of x. So let's use f of x. And f of x. Okay, f of x equals a, which we said is 2, sine. Our k value we said was pi over 2, bracket, x, and then I'm going to leave that last bit there for now. And then plus c, which is plus -3, so I'll write -3. Now remember that a sine graph typically starts in the middle, goes up, and then comes back. And so you'll notice this graph does exactly what we expect a sine graph to do. It starts in the middle, goes up, comes back down, and then comes back again. So this looks exactly like a sine graph right at 0 and -3, at 0 and -3. So you'll notice the phase shift, how much we need to shift it over, is 0. Didn't need to move it. So properly stated, we write f of x equals 2 sine, and that's pi over 2, and we don't need that bracket now, the x minus 0, because minus 0 didn't affect it, and we put -3. Now, fun facts, we can write so many different equations. It could also be f of x equals 2 sine pi over 2. I got to squeeze this in there. X minus and -3. I'm going to squeeze this in there, but notice we could shift it over 4 to the right, and it would have the same. So we could put -4. So that would be the same graph. We also could have called this, call it g of x equals 2 cos. Now let me go with cos here. Pi over 2 bracket. We got x, and we have -3. So if I were to make it a cos graph, what I expect for cos is that it starts at a max, goes down, and comes back up. So this is a maximum right there, if I were to be looking at cos. So if I think of that, that point right there is 1 and -1. So the x has been shifted over 1 to the right. So I'm going to put -1. And there we go. That one would also work. So you could give me this answer right here. You could give me this answer right here. You could give me this answer right here. And I've had students on tests have some fun and make the phase shift a massive number just to see if I could figure out whether they had the right equation. Challenge is yours. If you want to test me, you can test me and see if I can figure out whether you got the right phase shift. But there are many, many different answers for this. All right, so how do we sketch the function now? There are 5 different parts of the sine and cosine curve that we will graph every time. Pay attention to the maximum values, the minimum values, and the equilibrium point. So I want you to know the sine looks like this. So we're going to divide it into 4 segments here. 2 pi, pi, we've got pi over 2 here, and 3 pi over 2 there. Okay, and this is our graph of sine. To save myself a little bit of time right now, I'm just going to paste it one time here. Maybe I won't. Okay, I won't. This is not working for me. Okay, so, oh, it's working. There we go. Now we'll call this cosine. There we go. So sine graph starts in the middle. It goes up to 1 right there. Goes back to 0, goes back to -1, and then goes back to 0. So sine graph looks like this. Okay, And we can think of the points as being this, x and y. Okay, so at 0 pi over 2 pi, 3 pi over 2, and 2 pi. Okay, and we get at 0, the height is 0. Then at pi over 2, it's 1. Then it's at 0, -1, and then 0. And there we go. That's the graph of sine. And I encourage you to either memorize this graph right here or memorize the look of it right there. And we'll talk a little bit about that in a moment when we look at how to graph. Cosine, it's a lot like sine except for cosine starts at its max. So it starts up here, goes to 0, then it goes down to -1, then 0, and then back up to 1. So it goes like this. Remember, it's the exact same shape, exact same period. The only difference is its starting value. So here, you can also think about, well, what are the points? So at 0, at pi over 2, at pi, at 3 pi over 2, and at 2 pi. And the values are 1, 0, -1, 0, and 1, as we can see on this graph. Okay, again, I encourage you to either memorize the look of cosine there or to memorize those 5 points so that you have a basis for how to make the rest of your graphs after this point. All right, we're going to hit up on the graphing now. So transform the functions f of x equals cos x to g of x so that g of x has an amplitude of 4, a period of pi, a phase shift of pi over 4 radians to the left, and a vertical translation of 2 units upwards. So going through each of these values here, a gave us that amplitude is 4. Next, our k value. Well, it says the period is pi. So remember, period, or the k value is figured out by doing 2 pi divided by the period. So we do 2 pi over pi, and we get the number 2. So k is 2. Our next says that it has a phase shift of pi over 4 radians to the left. So we're going to go pi over 4 left. I'm just going to write it that way. And then it says a vertical translation of 2 units upwards. So that means our c value is going to be 2. So we've got c equals 2. And again, this d value right here, we'll talk about that in a moment. Okay. So if we were to write the equation, it said we're working with a cos graph. Okay, so we're going to write f of x equals a, which is 4, cos. Okay, right here we're going to put in our k value, which is 2. We're going to put x. And then now we're looking to shift left. So remember, to go left, we're going to add. So we're going to go plus pi over 4. And then the last number here is plus 2. Oops, plus 2. Okay, so that's our equation. And now it asks us for number 2 to graph g of x. Oh, I should have called it g of x, apparently. Here we go, g of x. Now we're going to look at graphing g of x on the graph here. So we're going to just set up a grid here. So we have an x and a y axis going along. I noticed it shifted up. So I'm going to draw my graph down a little bit. So make sure that I can fit it on here. Okay. And I'm going to use some key elements in order to label this, and this is where it gets a little bit difficult. So first of all, I know it goes up 2, and it's an amplitude of 4. So if we think of this as up 2, then 1, 2, 3, 4. So here we're at 6, and it's going to go down 4 from there. 1, 2, 3, 4. So we're at -2. You can see that I have a space there of 8, which is what I need because the amplitude is 4, which means it's going to go 4 up, 4 down. So my labeling system here will work. Next, we're going to look at the period. So I can see that the period is, it says that the period is pi, okay? And I often find that because we looked at these graphs earlier and it kind of goes into 4 sections, right? So 1, 2, 3, and 4. So there are 4 sections to these graphs that oftentimes what I like to do is just take the period and divide it by 4. So pi, and if I divide that by 4, it's pi over 4. So I'm going to go up by pi over 4. And that means this is pi over 2. Means this is 3 pi over 4, which makes this a pi. And then 5 pi over 4, 6 pi over 4, which is 3 pi over 2. All right, so that's my labels there. We're going to use two different methods to graph. So I'm going to do one graph like this where I use more the idea of the shape and we shift it. This one I'm going to take the method we learned earlier in the semester, which involves just taking the points. So our points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. So remember, these are the main points of a cosine graph, which is 1, 0, -1, 0, and 1. So these are our main points. Then we're going to stretch right now, okay? And so what we do to stretch each of these points is we look at the stretch factors. So our amplitude is 4, which means we're multiplying our y values by 4. Our period, the k, the period resulted in a k value of 2. And so because the equation says 2 right there, we're going to take each of our x values and divide them by 2. The next thing we're going to do after this is we're going to shift. And so shifting is our adding and subtracting. So for the x's, remember we were shifting them pi over 4 to the left, right? So we're going to subtract pi over 4 from each of our x's, and then on our y values, we were adding 2 vertically to the graph. So we'll take each of these transformations and apply them to the situation. So if we divide each of our x's by 2, we get 0. Pi over 2 divided by 2 is pi over 4. Next one is pi divided by 2, so that's pi divided by 2. 3 pi over 2, if you divide that by 2, is 3 pi over 4. And 2 pi divided by 2 is pi. When you divide by 2, it's like you're just doubling the base. If you're dividing by 3, you'd be tripling the base, the denominator. Now we're going to multiply each of the y values by 4. So 1 times 4 is 4, 0 times 4 is 0, -1 times 4 is -4, and we get 0, and then we get 4. Okay, so notice this is what our stretched graph will look like. It's a little bit taller, it goes out higher and lower, and it happens in less time. So now we have a period of pi instead of a period of 2 pi. So those are your stretches, and now if we do the shifts, what we're going to do is subtract pi over 4 from each one. So if you have 0 and you subtract pi over 4, you have negative pi over 4. Pi over 4 minus 0, sorry, pi over 4 minus pi over 4 is 0. If we subtract pi over 4 from pi over 2, we have positive pi over 4. Then we have 3 pi over 4 minus pi over 4. That would give you pi over 2. And you might find it useful to look at a unit circle as you're doing that, trying to think through, because we're subtracting 45 degrees here, right? And pi subtract pi over 4 is 3 pi over 4. Now we add 2 to each of our y values. So we got 6, 2, -2, 2, and 6. We can go to our graph now and label this. So at negative pi over 4, it's at 6. At 0, it's at 2. At pi over 4, it's at -2. At pi over 2, it's at 2. And at 3 pi over 4, it's at 6. And so we can see the graph comes down, goes back up again. And this is going to continue. Okay, so at this point, I like to look at the pattern. So if you think about this, it goes over 2, and then it goes down 4. And then it goes over 2, and then down 4. And then from here, we go over 2, and we go up 4, right? And we do that again twice in a row. So we go over 2, down 4, over 2, down 4. And then we shift it back up again and up. So every 2 units on our grid here, we're making a move, either up or down. And this will continue. These are at least 5 significant accurate points. It's a great way to graph this. If you're looking for more of a generic approach to this, we always start with the parent graph right here. Okay, so that's either the sine or the cosine. We're always dividing by our k value. We're always multiplying the y's by our a value. We're always taking, this is our d. So remember, if it's left, we subtract. If it's right, we add. And it works the opposite of what the equation says. And then here we add our c value, whatever that might be. So that's a generic way to do this every time. This is one way to graph it. It's not the only way to graph it, though. The second method involves graphing the stretched version and then doing the shifts. This one's a bit more of a visual perspective of doing this. So we're going to look at the function of y equals 3 sine bracket x plus pi over 4 minus 1. So first we acknowledge the amplitude, and here the amplitude is 3. The period is equal to 2 pi divided by k, and we can see that the k value there is 1. So it would be 2 pi over 1, or simply 2 pi. We're going to describe the phase shift, so that it says pi over 4. And because it says plus, it's actually pi over 4 to the left. And then this last thing here, the minus 1, represents our vertical translation, so that tells us it's 1, and it's negative, so it's down. Now we're going to sketch the graph of the function for 2 cycles. And how are we going to do that? We're going to first graph the stretched version. So stretch involves the amp and the period. So we'll acknowledge those two things, and then the shifts are the left, right, up, down portion. So our amplitude here is 3, and our period is 2 pi, as you can see above. And our shifts are pi over 4 to the left and 1 down. And again, we're going to do our stretch first, and then we're going to do our shift. So here on our graph, we draw our x and y axis. So here's our y axis. I kind of look into the future a bit, and I can see that it's going to shift down eventually, so I'm just going to make this graph go a little bit taller on the, or have more space on the bottom there. Okay, I like to think to myself personally, what's the period? And then I think, well, 2 pi divided by 4 is pi over 2. And there's a reason I picked the number 4, and I will always pick 4, is because if I'm looking at the graph of sine like this, I like to think of it as having 4 sections. So this is section 1 right here. Then it goes section 2 right there up to this point. Section 3 is going down to the minimum, and then section 4 is going back up to the equilibrium. So those are 4 sections, and it means that when I graph it, typically I graph 4 sections. I also look at the shift, because that's going to affect my x-axis labeling. And so it goes pi over 4, which is 45 degrees. So this is 45 degrees. Sorry. That's 45 degrees, and this is 90 degrees. That's what we're thinking to ourselves. So I'm going to make my grid go up by 45s. So it gives me pi over 4 there. 2 pi over 4, which is pi over 2. 3 pi over 4 pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and then 2 pi. Again, so we're going to look at the stretch version here. So it goes up 3 to 3, and it goes down 3 from the equilibrium. And it's a sine graph that we're looking at right here. So we expect sine to go like this, start in the middle, then it's going to go up, down, and up again, okay? Like that. But obviously not quite like that. And then the period is 2 pi. So that means from here out to here, it's supposed to do 1 full cycle. So we'll put a dot right here at 2 pi. So that's the full cycle. So I just drew this point and this point right there. Halfway between these 2 points is another equilibrium. So this is halfway between 0 and 2 pi. Halfway between that is this peak, the crest. And halfway between the third and fourth dot here is the trough, or the minimum. So we know that this graph looks like this. Comes down, goes across, and comes back up. Okay, so this is properly what we're expecting here. And that's the stretch version. And now for the final task, I'm going to do the shifts. So you'll notice again, we're shifting left pi over 4, and we've defined pi over 4 as being 2 squares there, and then it's going 1 down. So we're going to go left pi over 4, so that we're going to take this point, move it over 2, and then we're going to go down 1, and so this is the new point. We're going to take this point, move it over 2 boxes to the left, that's pi over 4, and drop it down 1. We'll do that with each of our points here. And so we have this. And if we were to continue, what you might notice is that for every 1, 2, 3, 4 boxes, it makes a move. It either goes up, or it goes to the middle, or it goes to the bottom. So I'll go 1, 2, 3, 4, and right here we should be at a peak. I'll move over 1, 2, 3, 4, and right here we should be at an equilibrium, and 4 over, and I'm off my page here, so I can't draw that part of it. The question asks for me to draw 2 cycles, so I'll just keep drawing this out. 1, 2, 3, 4. Now I should be at a minimum. 1, 2, 3, 4, and I should be in the middle. And there we go. That's 2 cycles there that we can see. And so that's how we do it from a bit more of a visual perspective, and we essentially just draw the stretch right away and then take the shift. Some of you may prefer to use these points like that, but either way, when you're doing this math, always make sure you stretch first and then you shift, because math is a rigorous subject, so you got to make sure you stretch before you do it. Last little question here. If a buoy bobs up and down in the lake, the distance between the highest and lowest point is 1.5 meters, and it takes 6 seconds for the buoy to move from its highest point to its lowest point and back to its highest point. It says A, model the vertical displacement V in meters of the buoy as a function of time, T in seconds. Assume that the buoy is at its equilibrium point, T equals 0 seconds, and that the buoy is on its way down at that time. And then it says B, sketch a graph. I prefer to start with sketching the graph here personally. So it says assume that the vertical displacement in meters of the buoy is a function of time, T in seconds. Assume that the buoy is at its equilibrium point at T equals 0, and that the buoy is on its way down. So we're going, it's going down, then up, and then down. Okay, this gives us a little picture of this. It says to do it for 2 cycles. Okay. What information do we have? It says the distance between the highest and lowest point is 1.5 meters. So high to low is 1.5, which means the amplitude is half of that. So we can think of this as 0.75, and this is negative 0.75. It says it takes 6 seconds for the buoy to move from its highest point to its lowest point and back to its highest point. So this should be 6, which means this right here should be 12. And we can label points all over this if we want. This would be 1.5. We could have all kinds of fun in this, but we'll just leave it right there. That's enough of a graph. All right, from here, we need to figure out the equation. So you can see that the amplitude here is 0.75. The k value would be 2 pi divided by the period. And the period, we said, was 6. So if we simplify that, that's pi over 3. And our c value is the vertical displacement. And so because we set this system up this way, we're right at the x-axis. So it didn't shift up or it didn't shift down. So we have c as 0. And then our d value is what we have to figure out. We'll talk about that in a moment. Actually, let's talk about it right now. So if it's a sine graph, what we would expect is for this to go up and then down, but it went down and then up. So we have 2 options. We can shift it over this far, and then it would start going up and then down. Or we could say, well, if sine is supposed to go like this, then a negative sign would do this. It would start in the middle and go down instead of up. So then it actually just looks like a negative sign. So we'll write both equations just to flex our mathematical muscles. So we've got V equals, we'll do A, 0.75, sine. K here is pi over 3. bracket x minus d. Well, if we go with sine, having to shift over here to make it normal, we're going to shift right 3. So that's x minus 3, and then we have plus 0. Or we could simply leave out that plus 0. And there we go. Another option, we could do v equals 0.75. Wait, we talked about making it negative 0.75 sine, and we have pi over 3, and then we'd have x. And if we do negative, we don't have to shift it because that allows it to go down first. We could use a cos graph too. Cosine would work just fine, but we won't. Well, that's the end of the school day. As you can hear the bell ringing, it's also the end of the lesson. So I hope this is helpful, and I hope you can rewatch this if you need to rewatch parts of it. Again, I want to remind you, you can graph this way. Works really good. Or you can graph using points and then stretching and shifting. But make sure you always stretch first and then shift, because math is a rigorous subject. You don't want to pull those muscles.